Hello champion, welcome to my math class. I'm teacher Adam. Today I'm going to teach you the unit of kinematics. So kinematics is one of the most important topic. Kinematics is one of the most important topics in math because it's also tested in physics. So for those students who are taking IGCSE Physics and those ones who are doing IGCSE Math, they will tell you like these topics are in both syllabus. So kinematics, what is kinematic first? We say kinematics is the study of kinematics. We say kinematics is the study of how objects move to cover a specific distance, and then from there we're going to see how they are related with other quantities like time. And then later on we might be asked to find speed, we might be asked to find acceleration of the object, we might be asked to find deceleration of the object. And then later on we need also to understand using our real life example. For example, a car moves, it moves from point A to point B. Then in between it has layovers or rest. Maybe it's going to a bus stop, and then later on they will have another driver after 30 minutes. Then you're told to plot to show that in graph. What are you going to do? So those kind of things. And sometimes you're told to find the total distance that a car moved. Maybe it is if it's a speed time graph. The kind of question what you're supposed to do. So we know kinematics is the study of objects in motion. We say then it looks how objects move over time. So we say kinematics, it looks how objects move. So it looks how objects move over time. So one of it is we have the speed time graph, which says speed time graph show the speed of an object at different times, and then we say speed is on the so speed time graph, we have speed which will be always on the vertical axis, and time is on the horizontal axis. So in graph, remember in graph we have y-axis, which is always vertical, and then we have the x-axis, which is always the horizontal. So this is horizontal, and then this is vertical. So we have the y-axis which is the vertical, and then we have the x-axis which is horizontal. Then we say now it looks how objects move over time, and then we say speed time graphs show the speed of an object at different times, and then speed is on vertical axis, the time is on the horizontal axis, and then say the gradient of the graph is acceleration. So for example, if you have the gradient, if you're looking for the gradient of these things, like maybe a car is moving, let's say a car is moving from this point as it goes by, and then later on you have we have point A, point B, and then we say what happens says the gradient of the graph is acceleration. We say the gradient of the graph is acceleration. For example, we're trying to find at which maybe the change in motions from one point A to point B. We say that is acceleration. Remember, is a change in motion. It can either be an increase. An increase is acceleration, a decrease is deceleration. Okay, so we say the gradient of the graph is acceleration, whereby acceleration is calculated by rise divided by run, whereby the rise is the change in speed and run is change in time. Okay, so a positive gradient shows positive acceleration, which means speeding up, and a negative gradient shows negative acceleration, which means slowing down. This is called deceleration. Okay, and then we say a straight line shows constant acceleration. So when you have a graph, like for example, you have a graph like this one, this is x and this is y axis, and then it says that one, that pass at the origin, this shows a constant acceleration, like there's no change. And then a curve shows changing acceleration. So this, it shows a changing acceleration. An acceleration here will be different from an acceleration here because they are different points. There is a change on y, there's a change on x, and there's a change on y. And even here, it's different. It's different. If you're looking for acceleration here, will be totally different from the acceleration that will be at point. It will be totally different from the acceleration that will be at point B. Correct. Then what we need to do, we're going to now distance time graph. How does a distance time graph look like? That's distance time. So how are we able to differentiate between distance time graph and speed time graph? Okay, so we say graphs that show the connection between the distance an object has traveled and the time taken to travel that distance are called distance time graph. So that's the definition of a distance time graph. So we say it's a graph that shows the connection between the distance an object has traveled and the time taken to travel that distance are called distance time graphs or travel graphs. So that's the definition. I'm not going to write on it. And then on such graph, we know on such graph we'll have these things. We have y-axis and x-axis. And then we have scale. So we have time in minutes. Maybe 0, scale 4, 6, 8, 10, 12, 14, 16, as you go on. And then we have time, distance in kilometer, distance traveled in kilometer. So we have distance traveled in kilometer. And then we have, remember, so we say these are distance time graph. Maybe a car moved to a specific point, then it rested. Let's say a car moved to a specific point and then it rested for how long? It rested for 2 minutes. Then it continued with its motion to a point there. If you look at the graph here, we have distance traveled in kilometer, which is on the y-axis, and then we have time in minutes. And then, so we say, we know now a graph, a distance time graph will have distance in kilometers and time in minutes. And what we're supposed to do is just to analyze. So we now know, we look at the graph, can you see that it shows the following journey? Maybe the first thing, there's someone, maybe a car is moving, and then it moved for 4 minutes, and then it rested for 2 minutes. Then it started another journey and moved from 6 minutes to it used how many hours? 16 minus 6. It used 10. It used not hours. It used 10 minutes. 16 minus 6, which it used 10 minutes to reach to cover 8 kilometers. So you can see there a 2 minutes wait. There was a 2 minutes wait, and then there was some more as soon as the car rested. So that's how we need to analyze. So in analyzing this, what are we supposed to do? So we say, in this case, you have maybe a car moving. It used 4 minutes, then it rested for 2 minutes. Then the car moved from this point to a point here. It used 10 minutes to reach the final destination, but it covered 6 more kilometers from the rest. So it covered 6 more kilometers. That's it. So whenever we're asked for any question, like maybe analyze how far the car moved, you are supposed to know. You are supposed to know. Let's go to another question. You say, example of distance, say, so we have, let's assume Adam walks to school for 30 minutes and he covered and he covered 6 kilometers. He rested for 5 and he covered 10 kilometers. Show the above information in distance. So to show this information in distance time graph, we just need to understand how many kilometers did Adam do in total. There are 16 kilometers. So we can just have our y-axis. Draw. We can have our y-axis, our x-axis. So how many minutes did 1.5 hours and 30 minutes? That means 1.5 hours. We can change 1.5 hours times 60, that's 90 minutes, plus 30, that's 120 minutes. So we can say we have 0, 20, 40, 60, 80, 100, 120. So time in minutes, and then we have kilometers. So kilometers are 6 kilometers. So we say 0, 2, 4, 6, 8, 10, 12, 14, 16. So we say distance in kilometer. Then we show. So time in minutes. Say time. So he covered 10 kilometers. So we say, if you go back to the question, what does it say? It says Adam walks to school for 30 minutes and he covered 6 kilometers. So he walks for 30 minutes. For 30 minutes and he covers, so for 30 minutes and he covers 30 minutes there. And he covers 6 kilometers. So from there, Adam to that point. Then he rested for how long? Then he rested for 5 minutes. So you can say he rested for 5 minutes. Let's say that's 5. That's fine. Resting means flat zone. Then he continued and then he used 1.5 hours. So it means to there. That means after resting, he went straight to 16. Yeah, so after there, he went straight and covered the 10 more kilometers. So to school. So this is where the school is. So you can see this is a distance time graph. Now, if you are told to answer questions in this kind of format, it won't be hard. It will be the easiest concept ever. So champion, you will kindly solve the following questions in the same unit. Distance time graph, you'll be given questions and I will specifically want you to solve the knowledge behind it, because from distance time graph you have speed time graph, whereby we know speed is distance divided by time. So we are still using the same quantity, and we know to find distance is speed times time. And to find time is distance divided by speed. So all these quantities we have done. So what we are going to look at is how do their graph look like, and how are we going to apply the knowledge and interpret our graph. And we know how the graphs look like. If you have any question, comment in our YouTube channel or through our Instagram page, Adamside Education Center, or our TikTok account at Adamside International, Facebook. So if you have any question, please let us know. But that marks the end of our session for today. Next session will start on speed distance time graph, whereby I'll solve some questions related and show you how you can analyze questions. See you at the top champion. Bye bye until we meet next class.